Hello, and welcome to another video with statistics. And in this video, we're going to talk about scatter plots, correlation, and causality. Let's first talk about correlation and what that is in statistics. A correlation exists between two variables when higher variables of one variable consistently go with higher variables of another, or when higher variables of one variable consistently go with lower values of another variable. And in a little bit, I'm going to show you visually what that looks like. I think it'll make a little more sense when we can see visually what that is. But let me just give you some examples of correlation. For example, there's a correlation between the variables of height and weight. Generally, taller people will tend to weigh more than shorter people overall. This is like generally. And so in that case, we will see a correlation between those two variables. There's also a correlation between demand for apples, let's just say, and price of apples. That is, demand tends to decrease as prices increase. So that's really economics 101, right? The whole price, demand, all of that. There is a correlation between practice time and skill among piano players. So those who practice more will tend to be more skilled. Okay, so those are just examples of two variables that we would find correlations. Now, there are also a few types of correlations. One is there could be a positive correlation. That's where both variables tend to increase or decrease together. In that case, we have a positive correlation. A negative correlation is so the two variables tend to change in opposite directions, with one increasing while the other is decreasing. You could also have no correlation. You could look at two variables and there is just no relationship between those two variables. And we would just say, well, there's no correlation. But we also talk about the strength of a correlation. The more closely two variables follow a general trend, the stronger the correlation. And it can be positive or negative correlation. In a perfect correlation, all data values would lie on a straight line. Basically, you would see a linear graph. When we talk about strength, the reason why we say that is sometimes you can have a correlation, but we would call it a weak correlation. And then other times, it could be a very strong correlation. So let's go here, and I'm going to show you scatter plots. Now, what is a scatter plot? Real quick. When we tend to graph our data values, we graph them on a scatter plot to look for a possible correlation. And it's just a graph where each point represents the value of those two variables. Now, if you look at this example, this is what we would call a positive correlation. And because if you notice, it's generally, this is like your little dotted line. This shows the general direction of the positive correlation. And what it's showing you is that the higher weight, because we're looking right here at diamond weights and their price. Now the price is up here, right, on the y-axis, and then you've got the weight of the diamonds in carats here. And notice in this graph, basically what we're seeing overall with these scatter plots, with all of these plotted points, is that the higher the weight of the diamond, the higher the price of the diamond. And so that is what we would call a positive correlation. Now, let's look at a negative correlation. Notice here, now this is an example showing you life expectancy and infant mortality. And if you notice here, and this is showing you the different countries and where their values would be on this graph. Notice what this is showing here. This is so generally you'll have the scatter plot, and what you do is try to find this line of regression that shows the general direction that these plots tend to be going in. And in this case, the general direction is a negative correlation because as the life expectancy increases, right, you'll notice here it goes with a lower infant mortality. And then you've got the different countries. And this is showing you that the higher life expectancy generally goes with a lower infant mortality. And so that would be a negative correlation. And so I always kind of think, I'll look here, with a positive correlation, I think when you're going from left to right, always look from left to right, you're kind of going uphill right? With a negative correlation, again, from left to right, I'm going downhill. That would be negative. All right, so look at this example. The scatter plot shows 2 weeks of data comparing the actual high temperature for the day with the same day forecast, that's the left diagram, and then a 3-day forecast, which is the right diagram. And what we want to do is just discuss the types of correlation on each diagram. So the graph on the left is showing us a 3-day, okay, so I'm going to move this up a little bit, but a 3-day correlation. Whereas on the right, sorry, same day correlation, I just messed that up. The graph on the left is just the same day forecast, and then the graph on the right is the 3-day forecast. Now let's just talk about this. Looking here, remember, you always read from left to right. This is generally looking like an uphill, right? If I were to draw some line through here, I'm going uphill. And a little bit here too as well. They're also increasing as I go from left to right. So both scatter plots show a general trend in which higher predicted temperatures mean higher actual temperatures. So what do I mean by that? Both show a positive correlation. The points in the left diagram, if you notice over here, lie more nearly on a straight line. If I were to draw a line, they're very close to that. And that's what we're seeing with that, which would indicate this is what we would call a strong correlation, when they tend to be more linear, more of a straight line. The diagram, and it would be stronger than the diagram on the right, because notice this is not as strong as a correlation to the one on the left. Now, if you think about this, it does make sense because we do expect weather forecasts to be more accurate on the same day, which is here on the left, than if we were looking at it in 3 days advance. We're just making a forecast, but we're looking 3 days in advance. So we're not going to see as much accuracy as we would with the graph on the left when we're doing the same day. All right, we'll keep going here. Now, let's talk about explanations for correlation, because just because you have a strong correlation does not always mean what we call causation. And I'll get into that in a minute, but here are some things. Let's say you find a real strong correlation, but there are 3 possibilities to that. 1, the correlation may be a coincidence. It really does. There might be actually no relationship between them, and they just happen to have a strong correlation, but it's just a coincidence. 2, both variables might be directly influenced by some underlying common cause. And 3, one of the correlated variables may actually be a cause of the other. And so note, even in this case, it might only be one of several causes. So here's the thing. I've seen a lot of times where I look at a report and it says, oh, look at this strong correlation, so these 2 variables are related. But it's not always the case. And that's why we really have to always do more research when it comes to correlation. We really have to make sure that there is an actual influence from one variable and the other. Here's an example. Consider the negative correlation between infant mortality, right, that graph we looked at, and life expectancy. Which of the 3 possible explanations, so up here at the 3 explanations, for a correlation most likely applies? So I'm just going to go back up here. We're talking about this graph right here. We were talking about the countries we had here, and we noticed that there was a negative correlation. And looking at these 3 possible reasons, what might be a possible cause for that correlation? So if we think about the negative correlation between infant mortality and life expectancy, this is an example of a common underlying cause. So that would be number 2. Both variables depend on an underlying variable that we would call the quality of healthcare. In countries where healthcare is better in general, infant mortality is going to be lower and life expectancy would be higher. So this would really be number 2. The common underlying cause for that negative correlation would be the quality of healthcare. And that would be one of the things that we would say would be the cause for that negative correlation. Now, we do have guidelines for establishing causality because like I was saying, and this is very important, when we talk about causality and we're looking at, is there a cause for this correlation? We have to look at several things. Here are the things, okay? 1, look for situations in which the effect is correlated with the suspected cause, even while other factors vary. 2, among groups that differ only in the presence or absence of the suspected cause, check that the effect is similarly present or absent. Okay, these are our guidelines. 3, look for evidence that larger amounts of the suspected cause still produce larger amounts of its effect. So you want to look at, is this happening only in this small sample? Or if we were to look at larger amounts, would we still see this correlation? Number 4, if the effect might be produced by other potential causes, so besides what we suspect it to be, make sure that the effect still remains after accounting for those potential causes. 5, if possible, test the suspected cause with an experiment. This would be great if we could do that all the time. If the experiment cannot be performed with humans for ethical reasons, consider doing the experiment with animals, cell cultures, computer models. Computer models would be great. And then 6, try to determine the physical mechanism by which the suspected cause produces the effect. So again, I can't stress enough that just because you have a correlation, even if it's a really strong correlation, that doesn't always mean causation. And that's why it's very important to look at this in more depth, study it in more depth, do experiments if you can, because you want to make sure this is a true correlation between the variables. Another thing to talk about is that we do have something that we call our confidence in causality. So there is something called a possible cause. We have discovered a correlation, but we cannot yet determine whether the correlation implies causality. In the legal system, possible cause, such as thinking that a particular suspect possibly caused a particular crime, is often the reason for starting an investigation. So possible cause. 2, probable cause. Now we have good reason to suspect that the correlation involves cause, perhaps because some of the guidelines for establishing causality have been satisfied. So those guidelines we went through, maybe it met many of those guidelines. In the legal system, probable cause is the general standard for getting a judge to grant a warrant for a search or wiretap. So there is a difference between possible cause and probable cause. Probable, you've got more evidence now. And then 3, there is cause beyond reasonable doubt. So we found a physical model that is so successful in explaining how one thing causes another that it seems unreasonable to doubt the causality. In the legal system, cause beyond reasonable doubt is the usual standard for conviction. It generally demands that the prosecution shows how and why, so it tends to be the physical model we talked about, the suspect committed the crime. Note that beyond reasonable doubt does not mean beyond all doubt. So just a little note there. Here's some examples, okay, I want to go through real quick. Decide whether the following, so everything we just discussed, we're going to do, I think I have 3 examples to just do an overall review of what we just talked about, but applying it to an example, okay? So number 1, decide whether the following statement makes sense or is clearly true or does not make sense. In other words, it's clearly false. And then explain your reasoning. I found a nearly perfect negative correlation between variable A and variable B. And so therefore, I was able to conclude that an increase in variable A causes a decrease in variable B. Now, if you want to pause the video and think about your answer for a second, go ahead and pause because I'm going to go right into the answer. But feel free to pause and think about this for a second. But now I'm going to kind of discuss that. In this case, I would say that the statement does not make sense because a correlation alone, and we talked about this, a correlation alone is not enough evidence to establish causality. So just because I found a nearly perfect negative correlation doesn't mean I can say, okay, well, the increase in variable A definitely causes the decrease in variable B. This is when I would have to go through my guidelines that we talked about and looking at the different types of causes and do further examination. So no, the statement would not make sense because we haven't investigated enough. You cannot say causation just based on correlation. Correlation just allows you now to investigate further. Number 2, let's look at this diagram. State whether the diagram shows a positive correlation, a negative correlation, or no correlation. And if there is a positive or negative, is it strong or weak? Again, you can pause at any time. I'm going to go right into the answer. Look at this. This, I could draw a nice, perfect straight line, and these dots are going to be very, very close to that. Very linear. Therefore, I would say that not only is this a positive correlation, but it's also a strong positive correlation because it's very much linear, like that little guided line we would draw would be pretty linear. Now, let me go further on that. And so we're looking at this graph. We have girl scores and then boy scores. And so in a country, and this is 10 countries it's showing, by the way. In a country where the boy scores are higher, the girl scores are also likely to be higher. That's what this is showing you. So when we have a positive correlation, it's showing us that as the boy scores increase, so do the girl scores. And so that's what we would basically say. It's a strong correlation, and then you just kind of explain it in context to the particular problem. All right, one more. For the following pair of variables, what we're going to do is we're going to state the units that might be used to measure each variable, then state whether you believe that they are correlated. And if you believe they are correlated, state whether the correlation might be positive or negative, and then explain your reasoning. Altitude, so let me just explain what this is showing you, because this is similar to some homework problems you'll do. What you're going to do is you would be comparing, if you were doing this study, you would be comparing altitude and air temperature, and it's just along some route. Altitude. Okay, so let's start with that. If you measure altitude, most likely, if you were going to do this, the unit feet. We would probably use our altitude in terms of feet. So I'm so many thousands of feet in altitude, right, above sea level. So I would say feet might be used. And then to measure air temperature, now that depends. It could be degree Celsius or degree Fahrenheit. It just depends. But either one of those could be used, Fahrenheit or Celsius. Now, let's talk about correlation. We're looking at altitude and air temperature. Now, how do I say this? Okay. As air temperature increases, our altitude tends to decrease. Okay, so let me say that again. Typically, when air temperature increases, your altitude is actually decreasing. And so in that case, we would have a negative correlation because as one is increasing, the other variable would be decreasing. And that would make sense because the higher the altitude, the lower the temperature. And so in this case, that's why we would say this would be a negative correlation. All right, so we just talked about correlation and causation, which is discussed a lot in statistics. And we will talk more in the next video about some central tendencies.